and I'm going to be trying to give you a bit of a history. But I guess first a little bit about background about myself. Um, I'm actually retired now, but I've been working in um, biodiversity information standards. Oops, I got somebody raise a hand. Is that something you can manage, Miguel? I'm not looking at a chat or anything.
Yes, don't worry about that. I'll take care.
Okay. So I was trained as an ichthyologist originally, but I did a fair amount of ecology work as an undergraduate and a graduate student, and then got more into evolution and ultimately systematics. And very soon after doing a couple postdocs, I got into managing information in natural history museums, first at the Smithsonian, and then at another wide series of museums, but some of them freestanding, like the Bishop Museum in Honolulu or the California Academy of Sciences, and some of them affiliated with universities or other government agencies. So my focus is a lot on collections, but you know, I do have a little bit of experience with ecological information as well. So with that, I guess I want to just go ahead and, oops, why doesn't that get started? Okay, so what I'm going to be talking about is biodiversity information management, and particularly the integration of that data across the world and across institutions and disciplines. Understanding of biodiversity requires descriptions of a huge, huge number of physical phenomena, organisms and species. And you know, having a knowledge of those entities is sort of a requirement for understanding the processes that produce, maintain, and destroy them. Biodiversity information is collected from, as Miguel said, at the moment, right now, into GBIF, we have 1,500 or so institutions, but there's still a lot more to be added. And if you, depending on how you count them, if you even count individual citizen scientists, we're definitely getting into the range of hundreds of thousands, if not millions, of sources. So how do we integrate all of this information across so many sources? And it's really been a kind of a synthesis of disciplines. It requires, you know, sort of building this integration effort requires a bit of knowledge from computer science, information science, geographic information systems, and of course biodiversity science. From computer science, we get a knowledge of and theory of data structures and database management systems, particularly relational databases. And even distributed database management systems, and particularly what they call loosely coupled information systems, and those which are integrating systems that are managed by different entities. They're not under one organization. They're not under one corporation or one government agency. They're independently managed, and that cooperation is, in essence, voluntary. You can't fire someone for not doing it your way. And that means that you have to manage a lot of social issues. In information science, you need to understand search and information retrieval systems. Search kind of predates Google, and the internet search was sort of developed in library information systems, being able to manage all of the books and journals and articles that you know, in essence, text that accompanies sort of knowledge repositories. And from that, we have an understanding of metadata and how it's structured and is put together and synthesized and indexed in order to become searchable. With geographic information systems, it's a whole nother seminar. I'm not going to really touch on that, but you know, there's raster data and the operations on that, vector data and the operations on that also come into managing biodiversity, because it's fundamentally spatially oriented. And then in biodiversity science, we have to understand the flow of information from creation to the most usable kinds of resources. And then there's a lot of politics, so to speak, and understanding how projects and organization become financially stable and sustainable in undertaking integration. So there's a lot to cover. I'm going to cover some of the history, which isn't quite completely chronological and steady. It's going to have a couple of loops in it or so, but I'm going to touch on some of the major things that I've participated in the integration of data across museum collections and some of the primary, the biggest observation data sets. The first thing is going to be the Association of Systematics Collections, which was an entity relationship model first applied when we were learning about database design in trying to build database systems for natural history collections. Well, we'll get to the reasons for covering each of these in turn, but I'm eventually going to turn to the distributed query systems that we built, as sort of proof of concept, and then turn to the TDWG infrastructure project, which is part of our standards development work, and then to talk a little bit about GBIF and what's gone on there, and the collaboration in particular between TDWG and GBIF. So the ASC model, this really goes back to kind of ancient history, but as I said, we were trying to design collection database management systems, and at the time I was at the Smithsonian, and we were trying to move off of a mainframe computer and onto sort of networked information, with the sort of client-server database management systems that were coming popular at the time, or just emerging technology. And we needed to know whether, in fact, the same concepts were used across all the different disciplines that appear in a natural history museum. So we convened a 5-day workshop, bringing together experts from all of these different disciplines, and applied the methods of entity relationship modeling, trying to see if we could come up with a generic database design that would cover all of them. So the fundamental concepts that we sort of came up with out of that workshop, the model that we produced was actually a lot more complicated than this, but these are sort of the fundamental things. And that was that people go to localities and perform collecting events. You can go to the same locality multiple times, and from any given collecting event, you might collect 0 to many specimens or collection objects. And at least, well, usually one, but at least one, but potentially more collectors. And collectors can actually be a person, an organization, or even a vessel, which we had someone call it a platform at that point, because we were talking about machine observations as well. So this sort of, let's see, so I hope you can see my mouse, but so this triple here of sort of a locality collecting event and collection object has been core and pretty stable to the thinking that has come since then. And then the other sort of method that is used in entity relationship modeling is subtyping, and so that there are many different kinds of collection objects aggregated in a supertype, if you will. So we could have a collection object might be a bulk sample, a lot like a jar of fishes, or a single specimen like a bird, or even a specimen part. So mammal specimens are typically broken into skull and skin, or it could be a derived object, a whole host of things, including casts and molds from paleontological specimens, preparations like slides or photographs, lots of different kinds of things. And all of these things get cataloged in our collections. The identification of a biological individual or a lot the association with the taxon is actually not just the labeling of it with a name, but we think of it as an event as well, but it's an identification event performed by someone, and it associates a collection object and a taxon. And that can be typically multiple identifications over the lifespan, so to speak, of a specimen, because the things get re-identified as taxonomic concepts change and corrections get made. That same kind of subtyping that we saw with collection object is also used under agents. So those are sort of the fundamental things that we developed there. And this was, I think the significance was, sort of creating a conceptual model for modular software development, so we could be reusing pieces of software as we built systems for each of the departments in the Smithsonian, or and certainly NSF was interested in a much more generic kind of collection management system that they could be providing to all of the different natural history collections around the United States. But it also laid the groundwork for integrating things across organizations. And it gave us a bit of experience with applying the sort of the fundamental data management concepts from relational database theory, relational database management theory, including entity integrity, where every row in a table is uniquely identified, referential integrity, where every value used as a foreign key exists in another table as a primary key, and data normalization. Those were bigger topics back then. They've kind of been, I wouldn't say swept under the rug entirely. They're still valuable as you sort of begin to apply the methods and principles of information management to biodiversity data. But this, let's say, this was kind of just a sketch, though. We didn't have this fully fleshed out, and it wasn't ready to be implemented as a database management system that could be used in practice. The next thing that sort of happened in kind of a landmark was a fleshing out of that model. And I think the first one to sort of put the stake in the ground at that level might have been the Museum of Vertebrate Zoology's data model in 1996, where it was fleshed out and ready to be handed over to developers. So added the necessary detail for implementation, and ultimately led to a couple of widely used collection management systems still in use today, Arctos and Specify. Specify's model was kind of independently developed, but drew a lot upon this, and I ended up sort of advising for reviewing that model and working with the developers to sort of tweak things. So in particular, there were some additional concepts of field notes and derived objects such as photographs and sound recordings, and as well as putting in some logical things that helped you keep track of information that came from the same biological individual, whether it was a specimen or repeated observations of the specimens or repeated photographs of the specimen or of an individual in the field that ultimately became a specimen or not. But yeah, so we added all of these kinds of different concepts. So as we got into developing the sort of the fundamentals for our collection management systems, then we began thinking about how to pull all of this together, because the internet was really coming on, and the World Wide Web hit the scene, and people started to publish their data over the internet. And as soon as that started happening, people were going, okay, so what we've dreamed about for the last 15, 20 years is now coming to be a real possibility. But the thing was interesting is that we had kind of gone sort of completist, if you will, in developing the models for our institutional management, data management systems, there were some people that pulled together, they got the idea that just a sort of the simplest view of that information, if it were drawn together across lots and lots of different institutions, could really be valuable scientifically. We knew that, in essence, any question that you can answer from information with information from one museum or one collection, you could answer better from information from all collections, or as many as possible. So we started to build these distributed query systems, and they had to be distributed query systems where you didn't cache all the information centrally, but you had to sort of build a system that queried each provider individually and synthesized the information in real time, because people were very concerned about data ownership. And if you gave your information away to somebody else, would you then become irrelevant? Would anybody ever go to you to ask information, or would you just get subsumed in some, the dominant aggregator, if you will? So there was a lot of, concern about sharing information, and people said, well, I'm happy to have people query my systems, but and they don't have to do it directly from me, but I'm not sure I'm ready to give away the store yet. So there were a bunch of these systems developed. The species analyst, which ultimately became Digger and Darwin Core, came out of a project from the University of Kansas, the California Academy of Sciences, the Museum of Vertebrate Zoology at Berkeley. And ultimately that system had strong deployment via some NSF projects, the Mammal Network Information, MANIS, and the same for birds and ORNIS, and for herpetology with HerpNet, and there was also a FishNet. So strong representation from the vertebrate communities. In Europe, the Berlin Botanical Garden and Botanical Museum sort of were the host institution and innovators behind another project that produced BioCase and a data standard known as ABCD, which stands for Access to Biological Collections Data. There was a similar network developed by Conabio in Mexico called REMIB, and the Australians had been doing similar thing actually preceded all of us with the Australian Virtual Herbarium and a standard called HISPID. And that one, something like the Herbarium interchange standard for something anyway. That goes by the acronym HISPID. And then there was a network that was developed in Brazil as well. Let's see. So the outcomes of this, I talked again about the distributed query, because of this fear of allowing complete copy somewhere else would make the provider irrelevant. But in particular, the thing is that the real outcome was that the portals demonstrated the power of aggregation, where organism occurrence data, a simple model, could be integrated into a global data set before use by a user. So the subsetting of whatever that user's sort of topic might be, could be done by subsetting that sort of global model. So it kind of looks like this, where each of these blue squares and the green cans underneath would represent an institution. And what they would do would be to map their individual databases through a provider to a data standard. And this provider would then make each of these data sets appear as a common kind of a model. So you didn't have to change the structure of this local resource. You could be as simple as a spreadsheet or as complicated as a 100-table database model. But you could make it appear relatively simple, and according to a standard, or at least according to how the portal wanted to see it. So that was, this is kind of a simple diagram of the sort of concepts provided there. And note that the use of a data standard sort of comes in this space. It's the mapping of these individual resources to the common model. And the user who comes to the outside has to also use this common model to look at all of these data and to query it. So the realm of data standards at the time was kind of the domain of an organization called the Taxonomic Databases Working Group, or TDWG. And interestingly enough, this organization was founded in 1985 to promote biodiversity information sharing, but it was pre-internet. Their standards that they were talking about were sort of looking down the road at a time when people understood that this was probably going to be possible, but they were kind of proscriptive standards, like this is how one should do things correctly. But the other thing that TDWG does to promote information sharing is convening an annual conference of practitioners. So these are the people who are, you know, through the international community that are actually managing biodiversity information. Not all of them, because it does have a very strong flavor or sort of slant towards taxonomy and natural history collections, but it actually has people from the ecological world as well that had been participating and continue to participate. So TDWG has been doing three things: developing standards, convening the annual conference, and publishing those standards and guidelines. The big feature, though, that really makes TDWG a community is that it's open to anyone. It's kind of like an academic society or an association of biodiversity information managers, and anyone can come as long as you can get there, so to speak. When we try to meet around the world in places and alternate meeting locations so that it's difficult for people on a sort of a rotating basis and easy for people who might be hosting. So as I said, the internet coming online really made the possibility of data integration a real thing, and it brought the need for standards into sharp relief, so to speak, which is to say it really put the focus on the need for data standards. So in the late 90s, also, there were some people who were sort of from the science management world, you know, sort of administrating funding agencies and things like that, that really got together and understood that the biodiversity world really needed to pull information together, and this was not going to be something that could be done really on a volunteer basis. It really needed a lot of money, and it really needed to become a critical piece of science infrastructure. So there was an effort to basically develop an international or intergovernmental agreement that countries would sign up to, and the concept was to basically make GBIF, the Global Biodiversity Information Facility, an organization funded by countries, but open to membership also to international organizations. But that means that if you were just a member of the academic community or an organization within a country, or even a single museum or a state agency or something like that, you didn't really find yourself, you didn't really have a seat at the table at GBIF. You were supposed to work through your country representatives. But that was, you know, it was kind of necessary. When countries give a lot of money, they really expect something for their contributions, and so there had to be a sort of a management structure with a secretariat and oversight by member delegations. But GBIF was established in 2001, dedicated to making primary biodiversity information freely available over the internet. And in 2003, they took one of these projects, the one that was kind of the most broadly adopted at that point, this Digger-Darwin core pairing of a protocol and a data standards, and used it to develop a proof of concept that demonstrated that a few things. Well, first of all, that this distributed query process would not scale, and in particular would not support the value added that a sort of the data aggregator needs to do to data to really make it fit together well, such as like creating a master taxonomic index across all of these things and mapping it so that sort of the data used in each individual case would kind of blend together more effectively. So GBIF started to, in essence, cache what they were getting from their queries, and they began harvesting. And they definitely proved that that was going to be necessary to meet user expectations. And at the same time, what we witnessed was that there was a transformation among the provider community, that they got comfortable with the notion of having a complete copy of their data reside somewhere else, and that their use and value would not be completely subsumed by becoming part of a global database, in a sense. And it demonstrated, of course, that primary biodiversity data serves a broad array of fundamental uses and users, and that earned GBIF political and financial sustainability. So after proving that distributed query systems really wouldn't work, that you had to really operate on a cache of that data, GBIF began working on developing the tool set to make that much more effective, because what they found was the distributed query systems to go and harvest things was you couldn't get the complete quantity of data pumped through that system effectively, and we just needed to be sort of bite the bullet and optimize this for harvesting. So back to this sort of diagram, this conceptual diagram, I'm going to take a look at what goes on in this blue box, if you will, and blow that up. So here we have the blue box, and that's expanded into the integrated publishing toolkit sort of processes that go on there. And then down here, we have a resource that's expanded up. So you may have a local database that has a highly normalized data model, or could even be just a spreadsheet. But ultimately, what you need to do is to create a view in a relational database, or at least a report template that you can push a button and dump your database out through this into, in essence, a much simpler structure that conforms, at least structurally, to a data standard. So you get this extract, and then you apply the standard terminology for these columns. So you apply the mapping, if you will. You get to sort of map your local field names to the data standard names, and then you combine that with some basic metadata about that resource, some of the administrative data, and what the coverage is, and who's the manager, and all this kind of stuff. And you put that together, and it all gets zipped up in a Darwin Core archive as a CSV file, separated values, and that gets copied to the portal. And that's a much more efficient process than we were getting with the distributed query systems. So that's how the IPT works. And this becomes a separate web server that an institution could put up, isolated from their own operational internal data management system. So that gives you better security and doesn't let any kind of activity out here put any kind of a compute load on what you're doing locally. But let me go back to this diagram. So I talked about this space up in here above we're touching on the blue boxes up here as being part of the standard. But in fact, if you had only one portal, this organization would dictate what that standard is. So the standard would be put out by GBIF, but GBIF didn't want to be or claim that it had to be the only portal. So what we ended up with, and what we've seen since, is that a number of thematic portals, well GBIF is, I would say, that the top aggregator, sort of aggregating all of the data. There are thematic portals that exist either regionally or taxonomically that provide a different sort of a view into data and provide further assistance to some providers that might not be able to host a web server. And then these thematic portals themselves can actually get harvested into GBIF. So this is kind of the structure that we have now. And again, because these things, all of these things are under different management, this whole notion of coming up with a standard where people come to the table and agree upon things and maintain and evolve that standard becomes particularly important. So GBIF operated through its first iteration, first 5-year memorandum of agreement. It established the various programs within GBIF in terms of outreach and interoperability and a few other things. They got their technical infrastructure established, so web servers and their networking and their database servers and all the rest of that. And they set the foundations for provider registration, data harvesting and integration, and how to make the sort of the primary uses accessible or enabled through query, download, and mapping capabilities. And through all of that time and since, the quantity of the occurrence data has really just steadily increased. And this is a bit of a cheat. This is kind of yesterday's snapshot of what the global data set in GBIF looks like now. So this is sort of approaching 1.5 billion records, or 1.3, I guess, but it continues to climb. And it's really an impressive feat. But you can also see, of course, that what you end up with is the greatest density of biodiversity data where you have the greatest density of people and developed countries. And through all of that time, GBIF maintained a fairly, easy collaboration with TDWG as an open forum, because GBIF is in essence closed, as you can't go to a GBIF meeting just because you want to, but of course they can't do it all themselves, and in fact they draw a lot of their expertise from the community of data managers who come and meet internationally at TDWG meetings. So one of the fortunate things that happened during the early years of GBIF was that there was a program officer from the Moore Foundation came and got invitation to GBIF meetings, but also then, because GBIF and TDWG were meeting kind of side by side at the time, often, he was able to see what went on in the community of practitioners, and really this guy came to understand that to really sort of juice this whole process and bring biodiversity data together was going to require really beefing up the standards organization. It was basically run by volunteers. So we managed to get, in essence, a $1.5 million 30-month project funded, which began in 2005 and ran for basically 2.5 years. It funded an architect, a programmer, developer, and a manager as full-time positions for that duration, and paid for a lot of meetings so that people could participate in the work plan that we developed. It enabled us to revise the organizational structure and standards process, and enabled us to put together, in essence, a collaboration infrastructure. So a website with sort of a single sign-on set of systems, including a content management system, a membership system, publishing platform, and mailing lists. And so all of this operated well for about 5 years, but it was kind of complicated, and ultimately it had to be replaced. So we operated it for probably another 5 years beyond what was functioning effectively. So we've had sort of two periods, that TDWG information or TDWG infrastructure project period that finished in 2007, that saw us revise our constitution and modernize the organizational foundation, and revise our standards process. I'll talk about that more in a second. And we ratified a number of the standards that had been emerging up through that time. But then, so we operated again for a bunch of years, and as things got more and more difficult, we sort of rolled up our sleeves and had another go at things and revised the Constitution again, created a number of standing committees, and the chairs of those committees are elected from the membership and serve on the executive board. That's an effort to formalize or incentivize broader participation and bring in additional resources of effort. And we replaced our collaboration infrastructure. So now TDWG is operating largely with services and platforms that are free or at low cost, and relatively, well, I don't know, maybe not appropriate to call GitHub simple, but it has uses well beyond TDWG. TDWG is barely a blip in its operations, but in fact, the kind of repository collaboration infrastructure that comes around open source programming is very akin to what we do with standards. Standards are invest in essentially a piece of code, if you will. It's not really active. It's a sort of conceptual specification, but the whole distributed collaboration infrastructure that you use in distributed coding, open source coding, is really applicable to standards development. GitHub also supports our TDWG website, and we've moved our sort of announcements over to MailChimp, and we have membership invoicing through a separate platform, but we don't really use that single sign-on kind of facility anymore. That was way too complicated. Okay, so we've had a struggle with our name. At the end of the TDWG infrastructure project in 2007, we had a sort of an awkward change of information to try and really tag what we do, which is making standards. So we now call ourselves Biodiversity Information Standards, but because people were reluctant to give up that old name, and because it has a sort of as Donald Hoburn used to say, a spiky feel in your mouth, TDWG really has stuck, and it continues. It's our domain name, and people are just reluctant to give it up. At the end of this most recent sort of effort to beef things up, we also established a journal with Pensoft, Biodiversity Information Science and Standards, and it is the sort of the vehicle for conference abstracts, for descriptions of standards, and for general contributions to biodiversity informatics. We also improved a new documentation standard for conceptual specifications. TDWG standards should now be expressed in RDF, which is a resource description framework. It's an internet standard that comes out of the World Wide Web Consortium. And its purpose, rather than for something like entity relationship modeling, resource description framework is really for integrating information from independent sources. And our standard also provides for incorporating elements for other standards. So we're all about reusing existing standards and not inventing everything within TDWG. Most recently, we've also increased the frequency of our executive meetings. So we've gone from sort of ad hoc meetings. The only thing that's required of the Constitution is to meet once a year. That's kind of a legal requirement, but now we're meeting twice a month on the second and fourth Tuesdays. We're having conference calls to try and accelerate the pace of what goes on there is enough business to keep us all busy, more than enough, if you will. And we've been hosting or convening annual conferences every year since 1985. And this is just sort of a quick graph of when I began managing registration for those conferences back in 2003. I have all the data for that, and this is what we've been doing in terms of participation. So back in the early 2000s, we were sort of averaging around 100, but gradually that crept up to around 200. And then most recently in 2018 and 19, we've met with other sort of similarly oriented organizations. In 2018, we met with Spinach, the Society for the Preservation of Natural History Collections, and that even though we were in a far off southern New Zealand, in Dunedin, we had almost 400 people there. And in Leiden this last year, where we were in a sort of a Central European city, we drew over 700 participants. And that's because there have been so many more people getting involved, particularly from Europe, in biodiversity information management. So I wanted to talk a little bit about our standards development process. It's modeled also on other standards bodies that are active or responsible for the internet. The Internet Engineering Task Force, the IETF, and the World Wide Web Consortium, the W3C. And what we did was to formalize the notion of interest groups and task groups. And so when a group of people thinks they have a common interest in developing a specification that enables them to integrate information of some type, they develop a charter and describe what motivates it, what the scope of that information is, their goals, and the methods they're going to use, and they submit that charter to the executive. The executive is responsible for coordinating the activities of all TDWG's interest groups. And then once TDWG approves, or once the executive approves the charter, TDWG allocates collaboration space in GitHub and posts the charter on the website. So you basically hang out and interface. This charter serves as an interface to the outside world to, this is what we're on about, this is what we're doing, this is where we're going, and this is how you can participate. So they work diligently for a while, usually, and then submit a specification or a draft standard to the executive committee for ratification. And what the executive committee does is appoints a review manager, and who then seeks expert review. Once those reviews are back and there's feedback to the proposers of that standard, the executive committee gets the result of that review and basically decides whether there's additional changes that need to be made or whether we can just go and open it up to public review. So we do both. In essence, we found that if you just put a standard out for public review, they tend to be kind of passive about it. It's like, okay, if they want to do it, fine. I won't stop them. But where we got our real feedback and real thorough review comes from the expert review. So that was kind of like what you do with a journal paper, in essence, or a manuscript. So the combination of both of those things, sort of making it open ultimately, but also engaging expert review is what's required to get something ratified as a TDWG standard. And the other thing that's really critical here is that interest group has to commit to maintaining the standard. No standard is ever complete. They always get evolved or they get ignored. Somebody builds something else. All right, so the other thing I want to touch on is how does standards development work in practice? Well, it's easiest if you have a project of developers and users and resources that can all be brought together and funded. You can get meetings done and all the rest of this. And you have sort of built-in providers and users. and you can create your specification and you can make this thing work and demonstrate it. But there are some things that play against just doing it as a project. One is that projects are typically funded within a region and you end up with a limited set of users. And projects usually have a sunset. So the funding will end at some point and you need to sort of move into a sort of sustainable operation somehow. You need partners to expand that reach globally. And there's a resistance to, if you come with a finished product, there's this phenomenon of not invented here. There's a reluctance, or you may have found that somebody in another region may have been doing a similar sort of thing, and you end up with a Darwinian competition where, in fact, some collaboration could have helped to sort of ease the adoption and really spur the broader benefit, if you will. So what we do is we encourage people to bring their projects to TDWG, to announce them at the conference early, to see whether there are people around the world that are also engaged in similar efforts, and to basically to cultivate partners early, and to make that effort to make your specifications, particularly the conceptual part, as a collaborative effort. So last slide, the sort of TDWG landmarks, if you will, and notable things. You can find out the basics about TDWG by going to the TDWG website. That's simply tdwg.org. The links are here. Make sure that if you go to the About TDWG, if you're learning about it, to read the basics part. So I've linked that down. It's basically scroll down on the About page to get to that. We have a page that lists our existing standards and our active interest groups, and all of the abstracts from past conferences, at least back to like 2006 or something, are accessible. And we have our next conference coming up, which will be the Biodiversity Summit in Alexandria, Virginia, September 20th to 25th, which is going to be another joint meeting with iDigBio, the GBIF governing board, and TDWG, and it's going to be sort of 2 days of working meetings and 3 days of joint symposium and contributed papers. We're expecting, I think, about 400 people, so another big meeting. And lastly, I want to highlight that we've got emerging specifications coming out of our data quality interest group. So we have a framework for assessing and improving data quality, as well as tool sets that are being developed. We have guidance for developing controlled vocabularies, because what is really going to make all of our data more effectively interoperable is to be using the same kind of terms for things, so getting down into content a little more deeply. And then we have collections descriptions that's going to be, it's currently under development. There should be dashboards showing up first prototypes, showing basically an overview, if you will, of the landscape of biodiversity information resources, something that's been lacking for a long, long time, if you will. So with that, I would be happy to entertain questions for at least 10 minutes or so.
Thank you so much, Stan, for that enlightening talk. Yeah, there are some written questions. I will read them. But if someone is interested in asking the question themselves, please raise your hand and I'll be happy to unmute you and you could answer live. Thank you. So the first question, I guess, was kind of answered later in the talk, but I'll still read it. Wouldn't cache the information make the system more efficient in the aggregation efforts?
Yes, yes, that's what we're doing. That's what GBIF does. So that's the way search is really effective, is to be able to pull all that information. And that's what we mean by a data aggregator. It's not just sort of virtually aggregating, it's actually physically aggregating.
I see. Thank you. Second question. What are the mechanisms that demonstrate the return for countries' contribution to solve local or country level problems using GBIF data? if any?
Well, so that's kind of up to the country delegations, the people in country. They keep a very good sort of log of access to GBIF data, all the downloads and where they go to. And they really have to sort of rely on sort of the people who write papers to report back those papers and to reference GBIF. And people are getting much better about that, in part because when you write a paper or create some sort of analysis, many places want to point to an archive of the data set they used. And GBIF does that, assigns a DOI now to every download that goes out of the GBIF system. And so GBIF, does a lot of work trying to, in essence, help the country delegations demonstrate the benefits into biodiversity management and sort of real effects, whether it can be in understanding zoonotic outbreaks and the biodiversity that is, the juxtaposition that is around that, to protected area development. I mean, Canabio actually has sort of some of the best, first and best demonstrations of the kinds of products that can be developed. And I would particularly point you to Jorge Soberon's keynote talk at the Biodiversity Next conference this last year. And you could follow, basically search for Jorge Soberon.
Excellent. Thank you. That's a really interesting. Let's wait for the next question. Jorge likes to say that GBIF data is not for beginners. What about the issues with GBIF data? What are the current efforts to support the community in using the data correctly?
Yeah, that's I guess that there's you have to, when you get your data from GBIF and you're analyzing it, you have to be aware of the kinds of caveats that people throw up about that. Certainly all the taxonomic identifications have to be kind of examined critically. You have to know how difficult that taxonomy of those organisms is. So that's probably one of the biggest caveats. What we have always done, or one of the sort of basic principles of metadata science, is providing enough metadata so that a user can assess whether the quality of those data meet their needs. And so that's one of the efforts that has been, we have a very strong group in data quality, developing the framework and the tools for improving data quality. The data that has come through these pipes is definitely dirty to begin with. It's like if you went out and did a plumbing infrastructure around a city, there would be dirty water that comes through those pipes initially, and it takes sort of time to clean it up and apply filters and basically clean up that data.
Excellent. Good analogy, Stan. I have unmuted Kay Holwick for a question. Please go ahead.
Locally here, we have a lot of difference of opinion about taxonomy for certain organisms. How do you deal with that kind of differences of opinion about the basic taxonomy?
That's a tough one. You can't force your opinions onto other people, but so in essence, you have to try to understand what they've done, and then you make your own determination about how you want to deal with that. It's, I guess, the sort of the basic thing in sort of in species level is sort of lumpers and splitters, and you can never make a lumper split more finely than they want to. Potentially, there might be rules of geography that go along with saying, okay, everything from over here is really another species, and we can split that based on geography. But you kind of, have to, just be aware, and you have to kind of negotiate, if you will, or just, interpret the data as best you can, but know that those differences exist. I don't really have a good answer. I'm sorry.
Thank you, Stan. Don Faberlangen-Doing has another question. Please go ahead, Don.
Yeah, thanks. It's a two-part question. I guess first, is TDWG responsible for maintaining the Darwin core?
Yes.
And if so, then what process do you use to maintain it? For example, do you do it, except for code revisions, on an annual basis?
No, one of the things that we definitely wanted to do way back was to not tie things to the annual meeting. It's kind of, you make a proposal, it depends on what the nature of the modification would be, but if it's simple definition, adding terms, things like that, then they can get rolled out as soon as you have what people would consider a consensus built up around that. Sometimes like the most recent things that have been proposed had to do with invasive species, and there was a kind of an awkward, the concepts around the occurrence of species, the status of an occurrence in an invasive, an area where they're invasive is a complex set of concepts, and the vocabulary around that was really horribly managed, and there was just getting a lot of garbage into that field. So a number of people from the invasive species community got together and proposed a series of things. So you can find a recent publication in our BIS journal on that, and I think basically they're sort of ready to shake the tree and sort of push that through as a set of changes to the Darwin core. But basically, you try to reach consensus in comments, and those changes get made.
Okay, thank you. Jaime Rodriguez has another question. Would you like to ask your question? Okay, I guess no. So the question is, hi, I would like to know the level of response of the countries about SABSTA, the subsidiary body of scientific, technical, and technological advice, recommendations of the CBD to use common data standards as TDWG standards.
I'm not sure how to answer that question. You can see from the list of providers in GBIF that that unless they're doing a network on their own, if they're feeding data into GBIF, you really need to be either expressing your data as Darwin core or ABCD. GBIF can harvest both kinds of data. And so you kind of look at, are there providers in that country? And if not, what's the reason? Is it lack of infrastructure? Is it lack of data? Is it lack of awareness? Typically it's just a lack of resources. Don't know if that answers your question, but it's definitely the GBIF is and TDWG as international organizations are doing their best to accommodate the needs of countries and regions around the world.
If I can also add to what you will say, Stan, there has been a lot of interactions between SABSTA and GeoBond, and GeoBond is an extremely good ally of GBIF. So they are promoting the standards that TDWG is producing via the interactions of GeoBond. Okay, one last question. Could you please elaborate on how to protect sensitive data hosted locally I want to share, but somehow blur the locality information.
Yeah, there are a couple of, there are some recommendations that exist. I don't know the answer to that off the top of my head, but, basically you end up kind of fuzzing that data. But the one thing that you got to watch out that in blurring the locality data, reducing the accuracy, that you do it in a way that doesn't allow repeated query to sort of use the long-term average to hone in on where that point actually is. So when you do that fuzzing, you do the blurring and in essence displace a point or reduce the accuracy, you have to do it well enough that and do it once. So you're not doing it at read time, but you do it at do it once, and then you store that sort of fuzzed, blurred, redacted version of that locality with the original. And Darwin Core has and ABCD have sort of flags for noting that the locality is that additional data is available to sort of qualified users.
Okay,
thank
you. We're 3 minutes past the hour. We have additional questions. I'll be happy to pass those to Stan, and he perhaps is going to be kind enough to answer them, and I can send the answers to the people. But thank you so much for participating on this webinar series. Thank you so much, Stan.
Yeah, one thing that I would just want to say is that if you consider yourself to be a practitioner of biodiversity data management, take your next best opportunity to participate in an annual TDWG meeting.
We'll be in DC, right? We'll be in the DC area.
Yes, the next one.
Okay, excellent. Thank you. Thank you so much, Stan. This was wonderful. Thank you.
Great. Thank you.